Hi folks, this is question 5. Part A is mostly just, um, well, it's working out the mean standard deviation, and then you have to get a correlation of coefficient. So the easiest way to do that is to use the calculator. So if you just put in the values into a table and then hit the correct buttons, and just it'll tell you what the mean is. Or if you want to figure out the mean, you can just add all the numbers together there and divide by how many there is. But calculator is the easiest way. So for the mean, we should it's the x with the little line above it, and we should get 2.4. Yeah, and then for the standard deviation, you'll have to put in values again and just hit standard deviation, and you should get 1.6. Or you could use the formula either for standard deviation. Correlation coefficient, you'll have to go back, you'll have to put the values of the reds and the greens into the table in two parts, and then look for correlation coefficient, and you should get minus 0.762 there, and it's a negative correlation coefficient. Now the third part here asks you to explain why the correlation coefficient is negative. So if you think about it, if you take out a lot of a certain color, well, then you can't be taking out many of another color. So for A there, he takes out 4 greens, so therefore you can't have a lot of reds then. I mean, you can never get 4 as well. Second one, you take out 3 reds first of all, so then you can only take out 2 greens, and you can't take out any blues, so the correlation coefficient is negative. So something like that. So if you give an example or something like that, so a lot of reds means not many yeah, well, this one was for reds and greens, wasn't it? So not many greens, so something like that. Right, so for part B then, so first part isn't too bad. So it asks you for the number of small face cubes with 3 faces on the outside. So the only ones are going to be the corners, because they're the only ones that are going to have 3 faces. Everything else will have 2 on the outside. So it'll be just this one, this one, this one, this one, and then the 4 on the back as well. So all of those will have that many facing outside. So you should get 8. So 8 corners of the cuboid. So the number of small faces with 2 faces on the outside. So think about the corner ones won't count here, but the other ones with on an edge basically will count. So this here, so that's 1, 2, 3. Then if you look down the sides, 4, 5, 6, 7 on the other side, and then on the bottom, so 8, 9, 10. So that's 10 on this kind of face that's facing us here. So there'll be 10 on the back then as well, if you think about it. And then there'll be a few more in the middle. So if you look on the side here, there'll be 1 there, and then there'll be 1 up at the top. So that's another 2. So now we've got 22. And the same here, there'll be this one here that you can kind of see there, and then it'll be the same on the bottom, but you can't really see it, but it'll be in there. So you should get 24 altogether, and they all just have 2 faces facing out. The number of small cubes with no faces on the outside of the cube. So get rid of all that for a second. So no small faces, so you can't have anything in the outside layer anyway. So if you think there's only 1 layer in there, widthwise, so therefore in behind that one there has to be 1. in behind that one there has to be another one, then in behind that one there has to be another one, in behind that one, in behind that one, and in behind that one. Everywhere else, for example, in behind that one won't count because that has that facing out. So it'll only be those 6. So we should get 6 in the end. And it's the cubes in behind those ones really, where I have the red dots there, if you can imagine where they are. So that's it. That's all you have to do then for that question.